All right. If you cannot hear me, let me know. Math 181. If you have questions, shoot me a text right over here. All right. So I'm gonna have live lectures on this, and then I have lectures on my website, and then also on Pearson. You could use Pearson tools to do that. All right. So the first thing we're gonna start with the tangent problem. All right, let's try to understand calculus. So the first part of the calculus is, let's try to understand what is a tangent line. Let's say that's a curve. If I draw a straight line right over here on the point P, make it smaller. This is the point P. We're gonna call that we're gonna say this is the tangent line. This is the function y equal f of x. The hardest part for this section, well, if you look at the tangent line on this curve, it doesn't look that important. I was like, what's so special about that? But this is very important. This is where calculus comes in. This is where all this modern science and mathematics was discovered because of this. Now you could understand the planetary movement, what happens, and so on. Let's see, how does this tangent line really help you understand what's going on? So let's look at this. Slope of a line. What's the formula for the slope for a line? Y equal, the slope, we use the symbol m. It's y2 minus y1 over x2 minus x1. Or some of you guys wrote it as y1 minus y2 over x1 minus x2. So whenever you have this formula, what does that mean? So you have a graph, and here's the line. You get 2 points right over here, right? That's your, let's say, x1, y1, and this is x2, y2. And it's pretty easy to find I don't take attendance, but thank you. All right. Given 2 points, it's easy to find slope of a line. But how do you find a slope of a tangent line? You have only 1 point. With only 1 point. Well, so we're gonna kind of cheat. So this is what we're gonna do. Let's let's get a curve, and what we're gonna do is, oops. Okay, so this technically is the secant line. Now you have these 2 points for the function y equal f of x. Now you can find the slope of the secant line, right? Let's call this, let's say x1. This is gonna be y1, x2, y2. And it's pretty simple to find that. And you could also write y2 as in f of x2, and y1 would be f of x1. But how can we use this slope for this one to find the slope for the tangent line? But let's figure out the slope for this. Slope for this would be f of x2 minus f of x1 over x2 minus x1. That's the slope. Now, what if I take this point? Okay, let's do it kind of like this way. Let's use this color. No. Let's try to find the slope of a tangent line at this point. That's the tangent line. How do I find the slope of that tangent line given this? The way it's going to happen is, I'm going to shrink this. Let me see if I can move this. Can I move this? Oh, I know how to do that. So what I'm going to do is, and then, can I rotate it? Oh, come on. No. So, okay, let's go back again. What I'm going to do is try to visualize this secant line. Okay, we'll do it the other way. What we're going to do is try to imagine that secant line becoming this secant line right now. And then this new secant line. And then eventually that secant line will become just like this line. So that's what's happening. Now, instead of saying it x2 over here, I'm going to say this distance delta x, and the new point is going to be x plus delta x. So therefore, the slope is going to be what? X plus delta x minus x1. On the top, you write f of x1 plus delta x minus f of x1. Y'all see that? So if I simplify that, my slope becomes what? F of x1 plus delta x minus f of x1. It becomes just delta x. The calculus comes as this. Do you guys see this change right over here? What is happening? It's as this secant line is getting closer to the tangent line, delta x is getting smaller. Or we say as delta x goes to 0. So as delta x gets smaller from this big to smaller delta x, then again another smaller delta x, and then eventually this delta x gets so small that it goes to 0. So as delta x goes to 0, we get a tangent line. So for m, as delta x goes to 0, we get the slope for the tangent line from the secant line. And that's your, basically, this is what we call a derivative. That's what we'll be looking at over and over again. And you have seen this. It's called quotient formula in your pre-calculus. All right. Today's lecture, I'm not gonna make it that long. Um, I see 13 of you guys are watching, and I assume you guys. I have 31 students who sign up for my math lab, and the due dates will get updated right after my lecture. Actually, I can update it right now. Come on, y'all. I hope you guys are enjoying the weather. It's really cold. What is it? 25th, 26th, 27th, and then 28th. I've just updated the deadline. Due dates. Okay. January is over and you want to feel like it's winter. Alrighty then. All right. So now we don't know that much about. We don't know mathematics about what happens to a function when something goes to zero. This concept is very new. And you guys haven't seen that. So what the heck is happening? What is that? So let's look at it. I don't enjoy the winter. Winter stresses me out. All right. Do you guys remember doing this type of problem a long time ago? X squared minus 4. And then if I say, what is f of 2? If you plug that in right away, you get 2 minus 2 over 2 squared minus 4. You get 0 over 0. That's a big no-no. You would be like, what the heck is going on? This makes no sense. But if you remember the trick, if you simplify that, x minus 2 over x minus 2 plus x times x plus 2 simplifies that. It becomes x plus 2. So therefore, f of 2 gives you what? 1 over 2 plus 2, which is 1/4. Now, how's that happening? What's happening? Do you guys, if you would try to graph this, what would it look like? Let me go back over here. Graph. If you would try to graph that, you would have asymptotes right over here, and I think your graph would look something like that. Something like that. But you had 0 at plus 2. Wait. You had an open circle right over here. Something like that. So 2 cannot be part of the domain. Yet, how was I able to get this f of 2 equals 1/4? What is happening? I see you guys are all enjoy snow. All right. So how is this right over here? The answer doesn't exist, yet my answer, I got f of 2 equals 1/4. What the heck is happening over here? So another way of looking at this, let me make a table. F of x. Let's see what happens. 1.99, 1.999, and then you put 2.001, and then 2.01. You you're not touching 2. That is correct. I'm not touching 2 yet. Why? How is that part of the domain? That's what we need to understand that. So if I evaluate this x, and then what is f of 1.99? So what I'm doing is I'm plugging into this function right over here. Or you could plug it into the simplified function too. If you plug that in, you get some interesting number. 0.2506, 0.25001, 0.2499, and then 0.2493. As you can see from the left and the right, you're approaching 1/4. And in calculus, that's exactly what we'll be doing. We're going to cheat. And we're going to get as close to 2. And as time goes on, where is the destination? Where is it taking you? And if the destination from both sides is the same, then we say that, yep, it's good enough. We'll accept the answer. And that's exactly what we'll be doing. But it has to reach from the both side to the same point. So let's look at a graph of it when it doesn't do that. F of x equal -1 and 1 if x is less than 2, and if x is greater than 2, it's 1. So if I graph this function, what happens? Let me use this colorful one. If x is less than or equal to 2, I get this open circle, and it goes like, I'm sorry, closed circle, it goes this way. And if it's greater than 2, open circle, and it goes this way. Now, if I say find the limit of this function as x goes to 2 of f of x, what do you get? As we approach approach 2 from the left, we get -1, and 2 from the right we get +1. So when this happens, we say the limit does not exist. The DNE means does not exist. So they have to approach to the same point. And also they cannot approach to the same infinity. Infinity is not a point that you could reach to, so therefore it doesn't even work. So let's look at another problem. Let me see, can you guys see this color? So let's look at this function. Or this way. Ooh, I'm liking this pencil. And let's make the point 1. If you look at it in both of the cases, as x goes to 1, first one you get infinity, the second one, as the x approaches 1, you get negative infinity and positive infinity. And like first one sounds like it should work because it goes to the same positive infinity, but no, because infinity is not a point you could reach to. So we call this limit does not exist, and it's also called as unbounded limit. All right, those of you who are gonna take calculus 2, no, I'm gonna teach calculus 3 next semester. Yeah, sorry guys, you guys missed out. If probably I'm not gonna teach calculus 2 next semester. I'm gonna teach calculus 3. But if you take calculus 2 summertime, you can take my class. It will be same time in the evening. All right. Do you guys want me to talk over the syllabus or accessing the materials? If so, just write it in the note. I could. Okay, someone's saying boo. Are you scaring me, or are you booing me? Wait, talk about the accessing of the materials? Okay, all right. So let me just quickly go over that. All right. So you have to go to Cognella. Not Cognella, I'm sorry. Pearson, click on Calculus 1. When you log in, I think you might want to talk about how you can access the materials. Go to my website, Math 181. Click. I have all the lecture notes. If you missed my lectures, you could download all these on your own. Click on the syllabus. This is my grading criteria. 85 to 100 is an A. I don't use plus minus. 72 to 84.99, and so on. These are my grading scale. Don't worry about the attendance. I don't do the attendance. The exam dates will be updated. The code. This is the code you're looking for right over here. You get 2 weeks free trial. If you don't have money to pay for it, you get free trial for 2 weeks. After that, you have to pay for it, and then you register for this. And the beauty thing about me using Pearson is if you go on to take, let's say, calculus 2, calculus 3 of mine, I think for two semesters you do not have to purchase the code, so probably cost you $110. And if you take my calculus 2 or calculus 3 without, basically you can take 2 semesters of my class. So if you take calculus 1, and if you would have taken my calculus 2, you didn't have to pay for this again. All you have to do is register for it, because I use the same book. So you use the same code for 2 semesters and you save a lot of money. Now, if you take someone else's calculus 2 and come back to my calculus 3, yeah, you could still, you will still be able to save money. And then just follow the instructions and so on. And then what you want to do is always click on class announcement. I have announcement right over here. Click on the do homework and quizzes, and I've updated some. These are very simple and basic. Homeworks are worth you get unlimited attempts. So you click on anything. You get 3 tries per. They're kind of tricky. So here they are. You put in the questions and so on, and then move on. You could save it. All right, that's what it is. And then quizzes are worth 2 attempts. Exams, you get only 1 attempt. Gradebook. Yep, and it will show what you guys are doing. Any questions right now before I go back to my lecture? No question? Alrighty then. Depends how fast or slow we could go. Maybe 1 to 2 sections, 3 sections. Sometimes it will be faster, sometimes it will be slower. All right, I'm gonna